Okay, welcome to 6.2, applying rational properties of rational exponents. This is when you will need the multiply and addition of fractions. So if you need a review, check on 6.1. And then here are all the properties of rational exponents. So similar to everything else, adding, subtracting, multiplying. All right, so here are some examples. But they work very same. You're just adding and subtracting fractions now for the exponents. So for part A, we have the same bases, and so we are going to add those exponents. Okay, so we don't have a common name, so we are going to multiply 1/2 by 2 over 2. And so that's going to be 7 to the 1/4 plus 2 over 4. So now that we have the same name, our final answer is going to be 7 to the 3/4 power. And that is all we can do. We can't simplify that anymore. For B, we have 6 to the 1/2. Okay, and that is being squared. So the first thing I'm going to do is multiply this in. So working every step, we're going to do 1/2 times 2 over 1 times 4 to the 1/3 power times 2 over 1. So when we multiply fractions, we multiply the numerators with the numerators and the denominators with the denominators. So we are going to get 6 to the 2 over 2 power without simplifying times 4 to the 2/3 power. And then 2 to the 2 is 6 to the 1st, so which we usually don't write 1 as the exponent. So our final answer is going to be 6 times 4 to the 2/3 power. So that is B. Okay, for C, notice we have the same exponent on the base 3 and 4. So I'm going to combine those into 4 times 3 to the 5th power, so undistributing, and then all of that is raised to the negative 1/5 power. Sometimes that's a lot easier. So inside we have 12, and then we're going to multiply the exponents. So that would be, working in small steps, that would be negative 5 over 5. And then to simplify that, we would get 12 to the negative 1st power, which is a negative exponent, so we're going to bring it downstairs, and now we have 1 over 12. Okay. These can be confusing because there's a lot of different rules that you need to pull from, but eventually, hopefully, it'll all slide into place. So for D, we have 5 over 5 to the 1/3 power, right? So we don't write it, but this is actually 5 to the 1st, and since we have the same bases and it's dividing, we are going to subtract the exponents. So that means we have 5 to the 1st power minus the other exponent of 1/3. Okay, we don't have a common name yet, so we're going to multiply this one by 3 over 3. So that would be the same thing as 5 to the 3 over 3 power minus 1/3 power. Right? And then our base is 5. We keep the same denominator of 3. And then 3 minus 1 is 2. And that's all the simplifying we can do. So that's our answer for D. For E, let me write that down. So notice, just like example C, we have the same exponent on 42 and 6. So, and I noticed that 42 and 6 can be divided evenly. So I'm going to rewrite this as 42 over 6, and then to the 1/3 power. That way I can reduce 42 and 6, and that is still being squared. So by that too. All right, so 42 divided by 6 is 7. So now I have 7 to the 1/3 power, and that is still being squared. Okay, so, and then I need to multiply the exponents. So when I multiply the top with the top, and so I get 7 to the 2/3 power, and that's all the simplifying I can do there. So those are those examples. All right, this example, pause it, figure out what's going on. Okay, I'm not sure why you would ever want to find the surface area of an animal, but we're going to go ahead and do that apparently. So we have the surface area, and we want to find the surface area of a rabbit that has 3.4 kilograms. So, and we're going to do this in grams. We're going to use that. We find our rabbit, our K, the constant for a rabbit is 9.75, so we're just going to fill in what we know and solve for S. So K is 9.75. Our mass, which is in grams, which is why we needed to change it from 3.4 kilograms to this in grams, is going to be 3.4 times 10 cubed, and then that is raised to the 2/3 power. Okay, and then we are going to simplify that as much as possible. So we have 9.75. I'm going to split the 2/3 power up, so we're going to have 3.4 to the 2/3 power times 10 cubed to the 2/3 power. Okay, so that's what we have so far. And then we can, I notice we can simplify this a bit, the 10. So we have 9.75 times 3.4 to the 2/3 power. And then I can multiply these exponents, so I would get 6 over 3, which is 2. So now we have 10 squared. All right, so when I put this in my calculator, I'm going to do these two first. So 9.75 times 10 squared, that would be 975 times 3.4 to the 2/3 power. Okay. And then when you put this 3.4 to the 2/3 power in your calculator, you should get approximately 2.261. And if you need some help with that, please ask tomorrow. But when you multiply those two numbers, the surface area for a rabbit is this. And that's how you do that. So there's your surface area. So for your guided practice, let's see. Number 1 is pretty straightforward. Number 2, you have the same base, so just make sure you get a common denominator before you add. Number 3, that would be 3 to the 1st, so that's very similar to another example. 4, I would notice 20 and 5 can be reduced, so I would rewrite that into a division problem with just one exponent of 1/2. And then for biology, you are going to find the constant for sheep. So good luck with that. All right, next we have properties of radicals. This is similar to properties of square roots, except now we have different ones. So if I had, for example, if I had the cube root of 8x, I know the cube root of 8 is 2, so I could split this up into that. This is 2, and then what I would have left inside is x. Now if I had 3 x's under the radical, I could take those out as well. If I had a 5th root of something and I was trying to simplify this, I would look for 5 of something. Okay. 5 of something to pull out of the radical. Okay, so our example for A, I'm going to rewrite this under the same radical, and I'm going to break down 12. So 12 breaks down into 4 and 3, and 2 and 2. So this is going to be 2 times 2 times 3. And then 18 I'm also going to break down. So 18 is 9 and 2, which is 3 and 3. So I have 3 times 3 times 2. So now I can simplify if I have 3 of something. So I notice right away I have 3 3s, so that can come out as 1, because 3 times 3 times 3 is 27, and the cube root of 27 is 3. I also have 3 2s, which is 8, and the cube root of 8 is 2. So I have no more radical, and my final answer is just 6. Okay. For part B, I have them split up, but I notice 80 and 5 can be divided into each other. So I'm going to rewrite that under the same. And then 80 divided by 5 is 16. So now I have the fourth root of 16. And I can break that down. So 16 is 4 and 4, which is 2 and 2 and 2 and 2. So notice I have 4 2's. So they all can come out to play as 1, 2. And that is my final answer. Okay. For these ones, writing the radicals in the simplest forms, again, we're just breaking it down. Since this is the cube root of 135, I'm looking for 3 of something. So 135, I know at least 5 goes into it. And then when you divide that, you get 27. So you can realize that the cube root of 27 is 3, or you can break it down even further. And then rewrite the prime factors under the radical, right? These 3 can come out to play as 1. So that would be 3, and then the cube root of 5, and we are done. 5 cannot come out to play because it does not have 2 other friends. All right, for part B works a little bit differently. I can't simplify 7 and 8 together, so I'm just going to leave them separate. However, I don't want a radical in the denominator. So if I write this differently, let's see, I have the 5. If I rewrite 8 as 2 times 2 times 2, if I had 2 more 2's, then I could get rid of the radical in the denominator. So what I'm going to multiply by is the 5th root of 2 times 2. And that way, everything can come out to play in the denominator, and then I can rationalize the denominator that way. So since I have 5 in the denominator, this is just going to be 2. And 7 and 2 and 2, I can't factor anything out. There's no prime factors that I have 5 of, so I just multiply those together, and I would get 28. Okay, I can't reduce 28 and 2 because they're not. All right, so that is my final answer. All right, like radicals, they have the same index and radicand. So what that means is if I have the cube root of 5 plus the square root of 5 plus 3 cube root of 5. Okay. Let's see, this has the same index, 3 and 3. These all have the same radicand, 5, 5, and 5, but it has to be both the same index and the same radicand. So this and this one are like terms, and this is like a 1. So when I combine them, I have one of these with 3 of those, so altogether I have 4. And then I write my label plus the square root of 5, and I can't combine that anymore. So that's what it means to have like radicals. So for A, I have the same index, the same radicand. So I have 1 of those and 7 of those, so altogether I have 8 of them, and it's 8 fourth root of 10, and that's my final answer. For 2, I do have the same. It's 1/5, which is the 5th root of 8. So I have 2 of these and 10 of those. So for part B, I have 12 altogether, and my label is 8 to the 1/5, and I can just leave it like that. For part C, we need to do a little bit of work. I don't have like terms. 54, and I have the same index of 3, but I don't have the same thing underneath the radical. So I'm going to break down 54. And 54 breaks down into 2 and 27. And then if you want to break it down further, you can break it down into 9 and 3 and 3 and 3. Right? So 54 will turn into the cube root of 2 times 3 times 3 times 3. And then these can come out to play as 1. So I have 3 times the cube root of 2. And then we can bring this down minus the cube root of 2. So now I have the same index and the same thing underneath the radical. This is kind of like a 1. So 3 minus 1 is 2, and my label is the cube root of 2. And that's my final answer. Okay, so for guided practice, you're going to break these down. Break down 27. For 17, I would rewrite it under the same, for number 7, rewrite under the same cube root, and then you could reduce 250 and 2 first. Number 8, I would split that up, and then find 3 more 2's, and 40, just break down 40. So, all right, for example 6, we're doing the same thing, it's just a little bit more complicated. So for A, we have the cube root of 64y to the 6th. All right, so I'm going to break down 64 and break down y to the 6th. Okay. So 64 would be 8 times 8, so you can recognize that they're both, the cube root of 8 is 2, or you could break that down further. So if I break it down into 2 times 2 times 8, 2, that's 1 8, and 2 times 2 times 2, that's another 8. And then y to the 6th, let's see, we have y cubed times y cubed. Okay, you add them, so that is definitely y to the 6th. And so we have 3 of these, so those are going to come out to play. Everything's multiplication. The cube root of 8 is also 2. The cube root of y cubed, and the cube and the cube root undo each other, so this comes out to play as 1y, and similarly the other y. So my final answer for A, we don't have any more radicals. My final answer is 4y squared. Okay, so that's for part A. For part B, all right, for part B, we are going to distribute the 1/3. So we're going to get 27 to the 1/3 power times p cubed to the 1/3 power times q 12th to the 1/3 power. Right? 27 to the 1/3 power, that's the same thing as the cube root of 27, which is the same thing as 3. We're going to multiply these fractions and get p to the 3/3, which is the same thing as p to the 1st. Q, we're going to multiply the fractional exponents and get 12/3, and that would be q to the 4th, and that is our answer for part B. For part C, I can split this up. This is going to be the 4th root of m to the 4th, and this is going to be the 4th root of n to the 8th, which I can rewrite as n to the 4th times n to the 4th. Okay. All right. So this one, say 4th root undoes the 4th, so on top I just have m. And then on the bottom, I have, let's see, so this can come out to play as 1n. This can also come out to play as 1n. So altogether I have m over n squared. Okay, if that confuses you, you can also rewrite that as 4n's and then 4n's. And then this comes out to play as 1n, and this comes out to play as another n. So altogether you have n squared. Okay. For part D, we are going to just do steps. So I notice 14 and 2 can be reduced. So I'm going to rewrite this as, let's see, 2, 7. So I have 7. And then I notice that z to the negative 6 is unhappy downstairs. So I'm going to move him upstairs. And then I'm just going to rewrite everything that I have left. So I have x times y to the 1/3. The only thing downstairs I have now is x to the 3/4. So when you have for x to the first and x to the 3/4, we can subtract those. So my little side problem, we can subtract the exponent. So we have x to the first minus 3/4. I need a common denominator, so this is going to turn into x to the 4/4. That's the same thing as 1, but now I have a common name, a common denominator. So altogether that would be x to the 1/4 power, and since I got a positive, that's going to go in the numerator. So I still have my 7, z to the 6th, y to the 1/3, and then I have x to the 1/4. Okay, and we usually write that in alphabetical order, but that's fine too. If I would have got a negative answer, that would have went downstairs, so it could be a positive exponent. That takes care of those. For example 7, for part A, we are just looking for 5 of something, right? So we have, let's see, 4 is 2 times 2. That's definitely not going to be 5 of something. A to the 8th, we can write that as a to the 5th times a cubed, or you can write out 5 a's and look for, or 8 a's and look for 5 of them. B to the 14th, I can rewrite that as b to the 5th times b to the 5th. And then that would be 10, and then I have 4 left, so b to the 4th. And c, I can just rewrite as itself, c to the 5th. Okay. And now I'm looking for what comes out to play. So a, the 5th root of a to the 5th is a. This can come out as 1b. This can also come out as 1b. And c to the 5th it can come out as 1c. All right, so on the outside I have a times b squared times c. And then on the inside, if I didn't have 5 of something, I had stay in. So I have 4a cubed b to the 4th. And that's my final answer for that one. For part B, it's a little more complicated. Remember, we don't like radicals in the denominator. So I'm going to split this up. Let's see, I have y cubed times y cubed times y squared. Right, so if I had another y, cube root of y, I could get rid of all the y's in the denominator. So I'm going to go ahead and do that. So I have the cube root of y times the cube root of y, which doesn't change the value. And so altogether I have 3 here, and 3 here. So 3 y's get to come out to play. So this comes out as 1 y. This comes out as 1 y. The cube root of y cubed is y. And then I have 2 here and 1 here, so those come out as 1. And then I can put that back together. So on top I will have the cube root of xy. And to simplify that a little bit more, I will have the cube root of xy over y cubed. And that's how you do that example. Okay, for number 8, we are going to, it's the same thing, just more complicated. It's the same thing as example 5, just a little bit more complicated. So for part A, we have the same index and the same thing under the radical. And I also have common denominators, which is nice. So I keep the common denominator, and 1 plus 3 is 4, and my label is the square root of w. So that's part A. Part B, I also have the same thing. It's xy to the 1/4 power. That would be x to the first times y to the 1/4. And so 3 minus 8 would be negative 5, and my label is x times y to the 1/4 power. For part C, there is a lot more to do. I don't have the same thing. I do have the same index, so that gives me hope for having the same thing under the radical. So there's not much, I can't do anything, I can do something. So for z to the fifth. So I have 12 times the cube root of 2, and z to the fifth I can split up as z cubed times z squared. Right? So the only thing that comes out to play here is the cube root of z cubed. So that comes out as 1. So for the first part, I have 12z times the cube root of what's left, so 2z squared. So that's the first part. The second part, so we'll keep that there. The second part is z times the cube root of 54z squared. Okay, so 54 is going to break down. We broke that down before, but that would be 2 and 27. And so to shortcut a little bit, I know the cube root of 27 is 3. So 3 comes out to play. And what's left inside is 2z squared. Okay, so now I'm going to put those two together. So I have 12z squared minus this. Okay. All right, so I simplified 12z. I simplified the second one. I've got the same index and the same thing underneath, which is 2z squared. So I have 12z minus 3z. So 12 minus 3 is 4. So I have 4z. And my label is the cube root of 2z squared. And that is my answer. So the key is to go slow. 10, 11, 12, and 13, you're all doing the same thing. So please follow the other examples closely. And like always, I will help you in class with the guided practice. Thank you.